All right, so we're going to go over basically what Chapter 9 was in Algebra 1 and using a lot of different methods. So today we're going to do factoring. We're looking at all the different methods of factoring, and then that's for solving a quadratic. As I mentioned, next week we're going to look at other methods for doing the exact same question. We're going to look at quadratic formula. We're going to look at completing the square. We're going to look at other methods that solve the exact same problem. So the nice thing about this upcoming quiz, test, however you want to think about it, is you really only have to know how to solve one problem or one type of problem. It's just that there's 3 or 4 different ways to solve that one problem. So if one way doesn't work, you can use another method. If the directions tell you to use this method, you can always, of course, do it that method, but then you can check with another method. So again, like the last half of the test, you can check every answer before you turn it in and know if it's right or not. Keep on working until you run out of time if you can't quite get it. It's a nice, comforting to know that there's a way of finding out if what you're doing is right or not before you say, I'm done and I'm all finished. Okay, and of course, what you want to be thinking about for everything we're doing is like, I would use what method and why. Okay, so I would use factoring method because da 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 da. I'd use completing the square because da da da. I'd use quadratic formula because da da da. Okay. When do you use what method and in what circumstances would be easier to use this method over another? Well, you're thinking about the whole time. So first, let's do a few exercises here. You might remember these. Go a long time ago. What two numbers multiply to the top number? Right, multiply to this number and add to this number. So like this one, what two numbers multiply to 56, add to 15, that'd be 7 and 8. So take a minute, go through these, see what you can find out, and we'll go over them. What multiplies to 28, adds to 11, 4 and 7, 4 and 7, or 7 and 4, the order doesn't matter. Yeah, go through those and we'll go over the answers. All right, for B, what'd you get? 8 and 4. 8 times 4 is 32. 8 plus 4 is 12. Letter C. 12 and 3. Yes, you might have to know your 12s in order to do all these. D. 8 and 6. E. F. 12 and 0. Good. G? Yeah. Yeah, it's a good clue that if it multiplies to 0, one of the numbers has to be 0.
Can there be negatives on these?
Yeah, there can be negatives, and we'll have some that are negative, yeah. All right, so watch up here. I want you to refresh your memory before you just start writing everything down. There'll be plenty of problems for you guys to practice on, but right now, just let it come back to you and try to remember all the details. You're going to remember the big stuff. You're going to remember, I do this X, then I do this, I do this. I'm going to be pointing out all the little common mistakes, all those little things, okay? So pay more attention to those. First little thing that's always coming up is that once you have a problem to solve, and a quadratic to solve, a lot of people automatically jump to doing what we just did. And they skip, try to look for GCF and looking for square roots. If 1 or 2 are possible, it is so much faster and easier if you do that. If you just automatically go to step 3 right here on every problem, it will make it more difficult. Okay. So GCF, how do you know if there's a GCF? You're looking for any numbers or variables they have in common. I'm talking about all the terms. So if there's 1 term, 2 terms, 3 terms, what do these have in common? So do you see any number that's in common? They have an X. Do you see a variable in common? Right now, yeah, there's X in both. That means it's a GCF. So what does GCF mean when you find GCF in factoring? Yeah, it's also known as reverse distributive property. This is the opposite of distributive property. Distributive property, you have something like this, like 2x and plus 3, and you say this times this times this. Factoring is the reverse. It's taking something out, the same thing out of every term. So what can we take out of both of these?
X.
X. So if you take an x out of here, what are you left with? X, take the X out of here, what are you left with? 4. Minus 4, yeah. Minus 4. And of course, if you do a distributive property, since what you just factored, it should equal what you started with. X times x is x squared, x times negative 4 is negative 4x. So just think of the GCF as the reverse of distributive property. And you can always check it. Okay. Much easier than doing all this box stuff. Next thing. We now have a multiplication problem. That's what factoring is. Taking stuff that's being added, subtracted, it's changing it to multiplication. Once it's multiplication, we can solve it. So our little squiggly line, the left-hand side of that line equals 0, and the right-hand side of the same line equals 0. On this particular problem, you don't have to solve, which is answered already. Side we get from. Notice how they're both x equals. So here's something you do not want to do. No, do not do this. Why not? Yeah, this would say x is 0 and y equals 4. You don't have any y's in this problem. So don't do that. Okay, so use set notation. Braces. So x is 0 and also x is 4. That's what this means. Graphically, what does this mean? Here's another big concept for the day. What does this mean? What does this represent on a graph? So these numbers right here are the x-intercepts. The x-intercepts. And when you're graphing linear graphs or straight lines, you're always caring about y equals mx plus b. What's the y-intercept? What's the y-intercept? With parabolas, quadratics, you care about x-intercepts. So these two numbers, here's what they tell me. 0 and 4. Here's what they tell me. If I go to graph it, I go to the x-axis, x equals. Where x is 0, that's right here. And x is 4. That's right here. There's 0, here's 4. And the parabola will go through those lines. Something like this. That's the meaning of all your answers. Every time you answer one of these for your homework tonight, I want you to be thinking about what their answer actually means. If you graph the parabola, that's where the intersect the x-axis is drawn. A parabola for them. Tomorrow's assignment is find out what is this point right here? How far down does the parabola actually go? So what's the x and y of that point? That's what we're looking at tomorrow. So we're just kind of easing into it. First find the x-intercepts, then we'll talk about this point called the vertex and where it is. And it's nice when there's two solutions. It's always right in the middle of those two solutions. So if I have one answer at 0, one answer at 4, I know this one is at. So this is going to be 2 comma something. But again, that's what we'll be doing tomorrow. We know it's in the middle. So it's a much bigger picture of what we're working on. It's not just look at answers and say, oh well. And this is a big idea. If I ask you, what do these answers mean? You tell me, those are x-intercepts of a parabola. Okay. A few more. Another small one. I'm not going to go through the whole problem, but before you start any of this, I'm going to say number 0. And you know what step 0 is? Get it equal to 0.
Oh.
So if it's not equal to 0, get it equal to 0. Step 0, get it equal to 0. So if I have a negative 30 equals negative 36, do one step and get it equal to 0. And then we can go ahead and start on step 1 and 2. if I was to do this, I'd look for GCF. There is none. Square roots. When I say square roots, what are we looking for? We're looking for perfect squares. Things you can take the square root of. We're looking for 4, 9, 16, 25. What's next? 36, 29, 64, 81. So if you have a problem that has all these numbers, then you can start taking square roots of both sides and things like that. We do have a 36 here, but then we also have a 12. Can't really do these square roots. So it doesn't happen often, just like GCF, it doesn't happen often. But when it does, it's much easier if we do that. And we'll do an example later. All right, so we do it this way. There are 2 methods that you guys probably seen. It's this X thing that you warmed up on, and also this box. I'm going to say to you right now, if you have any method that works for you better, then use that method. There are lots of things out there, depending on what school you went to, what teacher you had. I might show you different ways of factoring. Whatever works for you, that's the best way, okay? Here's what I would do. I would say, draw my X. The number that goes at the top, like in the warm-up, is A times C. A is the first number, which is 1 on the problem. B is the second number with the X. C is the last number, which is always by itself. There's no variable. Okay. What they are grouped with determines if they're A, B, or C. So the number in front of the squared is always A. The number in front of the X is always B. It doesn't have to be, it's like if this said plus 36 plus 12x, 12 is still B because it's with the X. The number by itself is always C. Doesn't matter where it is. You put 36 plus x squared, 36 is still C. So A times C would be just 1 times 36. 1 times 36 is C. And then B is going to be where? What 2 numbers work?
6 and 6.
6 and 6. Now here's what I'm going to do. I'm going to put the 6 and 6 right down here. And then whatever the variable is and the number, I'm going to put right above it. I'm going to write like a fraction. I'll put an x here and an x here. So my 2 terms are going to be x and plus 6, x plus 6. There's a good reason for this, which I'll show you on the next. Now we have multiplication, right? This is x plus 6 times x plus 6. So, a squiggly line. Now you notice that they're both the same. So, the answers will be the same. They both come out to negative 6. Okay, here's pop quiz. What does this answer mean? That's the x-intercept. Well, there's only one though, so what would that look like? Here's the x-axis. Here's negative 6. What would my parabola look like?
Down.
The bottom will be, yeah. There you go. The vertex is also the x-intercept.
You got it.
Right there. So one answer, one x-intercept. So it means the vertex and the x-intercept happen to be the same thing. So this one, especially for tomorrow, you're going to like this one because it's going to ask you, what are the x-intercepts? And then if you see, oh, there's only one, the next question is, what is the vertex? And you can know this. You say, oh, the vertex is negative 6, 0. It's the same thing. It's also going to ask you the domain and range. No surprise, right? So domain, once again, you can plug any decimal number into this if you want to. What's the range? What are all the possible answers? Where do the answers start? Where does this graph actually start? It starts at 0 and it goes up. So the range would be y is greater than equal to 0. Starts here and goes up. The range, you're looking at y values. Here's 0, and all the graph is up here. That's where all the y values are column. The graph does not go down here, so there's no negatives in the range. Again, that's all tomorrow. That's where we lead up to. Let's see here. What if this thing doesn't have any answers? What would a graph look like if it had no solutions?
Sideways.
Sideways. Well, parabola is always opening up or opening down. It just, what does it stand for again?
Vertex.
X-intercept? So it'd just be a parabola without an x-intercept. So this would be a parabola with no solution because there are no x-intercepts. This is no solution. And the new thing you're going to learn in a little while is that while this has no real solutions, it has something called imaginary solutions. It has some imaginary roots. So that's the one little thing that's new in chapter 5. Is that we're going to have some imaginary roots to talk about. Maybe. Okay. I'm just going to start this one. Not going to do the whole thing, but still just watch up here. I'll give you time to. You notice over here how I put this x, and I just put it on top. Well, here I'm going to be putting like 2x on top, because this is 2x. So I can set up this problem in the same way. 2 times. What number goes here? Negative 6. Yeah, don't forget, that's a negative 3. So it's 2 times negative 3 is negative 6. What number goes down here? Negative 1. Negative 1. So what's the negative 1? All right, what are the two correct numbers? 3 and 2, is that right?
Negative 3.
Negative 3. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. Now here's the difference. This time on top, I'm going to put 2x for both. You notice here, 2x over 2, that can be reduced just like a fraction. What does that reduce to? X over 1. If I divide top and bottom by 2, I get x over 1. So that's what you want to use as your binomial instead of 2. So that's why we do this way. So your two binomials will be 2x minus 3 and x plus 1. Don't use the 2x plus 2, use the x plus 1. Of course, that is just and the rest is the same. You'll get answers of 3 over 2 and negative 1. Again, what do these represent? X-intercept. How would you graph 3 over 2?
3 over 2.
Yeah, where's 3 over 2 on this x-axis? It is 1 and a half. So, yes, you might have to say, oh, it's 1.5, and then, there you go. Then, travel looks like this. Something like that. Goes to 1.5 and negative 1. Two solutions. Okay. Alright, have you guys tried Q? Sure. Skip that one. Yeah, it's that one. Like, you can't believe it. Give that a shot. Try it on your own first. If you get stuck, just look around, ask somebody, raise your hand. Don't just, well, I think I'm doing it right, but maybe not. See, the problem is if you go off and do it wrong right now, you do everything wrong in your homework. So if you have any doubt, check. And then, of course, when you finish, check just to make sure. Sometimes you go through a problem and say, yeah, that's really good. And then you find out after you do all your homework wrong, that's wrong. So better check. Try that. Just check. Let's try this out. We have A is 6, B is -4. So here we have -24. B is -5. So, what two numbers multiply to -24 and add to -5?
-8 and 3.
Right. -8 and 3. Okay. Over here we have a 6x. So above both of these, I'm going to put 6x. Alright, now just reduce the numbers like you would any fraction. What is 6 over 3 reduced to? 2x over 1. And we do want to put the plus 1. And what is this reduced to? 3x over -4. Right. So those are your two binomials. We have 3x minus 4 and 2x plus 1. Now, some of you know this box. We use this box a lot. To use the box, teacher taught you this. This is what you would be doing. You'd be putting 6x squared here, whatever a is, with the variables, put in here. Whatever c is, goes in the other corner. And then these two numbers that we just got over here, the it's -8 and 3, put those in the other two spaces with a variable. So we put -8x and 3x. Again, this is optional. This is the method that you were taught and the one that you know, and this is what works for you. You can use this. And you'll get the GCF of these two is, what can you take out of both of these? 2 and
X.
x. What can you take out of both of these? A 1. The 1 goes into both of them. That's the only number. Nothing bigger. What about this column? You have 3x and this column. A negative is a common, and then a 4. Alright, so you see how you get the same two. 3x minus 4, 3x minus 4, 2x plus 1, 2x plus 1. And again, there are so many other ways of factoring, it's ridiculous. So if you find a different way or you like something else that you already know about that works, it's fine. Okay, it's okay. I find people find this, find that one method. It's a little long when you put everything in the box and every problem. If you can do it in the X and be okay with it, then that's fine.